All right, welcome to the deep dive. Today we're going to get into something that I think, if you've ever messed around with trying to get data from websites, it's probably been on your mind.
Yeah.
And that is PHP web scraping in 2025.
Right.
Maybe you've been trying some stuff and it's just not working, or you're just kind of curious about how it's done these days.
Exactly. Yeah.
So to help us out with this, you sent over some really fascinating excerpts from an article. It's called Web Scraping with PHP in 2025, Modern Tools and Best Practices for Data Extraction Rebrowser. It's by Nick Webson. And it was published, I think, just last month.
Yeah. Really, really interesting stuff in there.
Yeah.
Some really cutting edge techniques.
Yeah. And so what we're going to try to do today is, really cut through the noise.
Right.
And give you a really solid understanding of how PHP is being used for web scraping today.
Exactly.
We're talking about what's fast, what's dependable, and what's, playing by the rules. Right.
Forget all those clunky old techniques.
Yeah.
We're diving deep into the modern stuff.
Absolutely. The modern era.
Yeah. So let's unpack this a little bit. So, in Nick's article, he throws out a couple of some really intriguing ideas.
Yeah.
So we're gonna look at why Symfony's DOM crawler and Guzzle are kind of like the power couple
Right.
of modern scraping.
Yeah.
We're gonna talk about why being ethical isn't just a suggestion anymore.
Yeah. It's critical.
It's really important.
Yeah.
We're going to talk about how asynchronous operations can really, crank up your scraping speed.
That's right.
Why browser automation is a must-have for those sites that are really heavy with the JavaScript.
Yeah, absolutely.
And how using rotating proxies can really make a big difference.
Yeah, it's really like a peek into the toolbox of a 21st century web scraper.
Yeah, that's a good way to put it.
Yeah. So, one thing that that the article really emphasizes is that the web has evolved.
Right.
And our scraping methods have to kind of keep pace.
Yeah, they have to evolve too.
Yeah.
But,
And so he really stresses how those older approaches like just grabbing a page with phylegic contents and then, trying to sort through it with regular expressions, those just don't cut it anymore.
No, they just don't cut it.
And it's really because of the complexity and, the dynamism of today's websites. They demand a much more sophisticated approach.
Yeah, a more robust approach.
Yeah. So, the article keeps mentioning these essential modern tools.
Right.
Symfony's DOM crawler and Guzzle, they seem to be, kind of at the heart of it.
Yeah.
For someone who might be used to those older ways, what's the real game changer with these?
Yeah. So, with Guzzle, Guzzle, it's not just fetching a page. It's really a very sophisticated tool for negotiating with web servers.
Okay.
Think about it. It handles different types of requests, manages cookies, sessions, it deals with redirects.
Right.
In a way that simple file-led contents could never, ever reliably do.
Right.
This robust communication layer that it provides is really crucial, for interacting with modern web applications.
Okay, so it's not just as grabbing the raw HTML. It's about actually having like a proper conversation with the server.
Precisely. Yeah.
Okay.
And then you've got DOM crawler. And the real power of DOM crawler, I think, lies in its ability to treat a web page like a structured document that you can query.
Okay.
So think of it as bringing the precision of CSS selectors and XPath directly into your PHP code. So instead of, wrestling with these often fragile, regular expressions to find the data that you need, DOM crawler lets you pinpoint elements with surgical accuracy.
Right.
This makes your data extraction, far less error prone, and it's much easier to maintain when website structures change, which they inevitably do.
Right.
Imagine trying to update a massive regular expression versus just tweaking a CSS selector.
Yeah.
It's a world of difference.
Yeah. Maintainability is that's huge. Nobody wants to spend hours, debugging a script every time a website gets a facelift.
Absolutely.
Now, the article also, kind of lays some groundwork, some prerequisites for diving into modern PHP web scraping.
Yeah.
And it's not just install a library and hit go, is it?
No, not at all. To really harness the power of these modern tools, you're going to want to be running at least PHP 8.1. This version, it brings some significant performance improvements and access to more modern language features that these libraries often leverage.
Right.
Then you've got Composer, which is absolutely essential. It's the standard dependency manager for PHP, and you'll use that to easily install and manage libraries like Duzzle and DOM crawler in your project.
Okay.
You're also going to need a foundational understanding of HTML and how the document object model, the DOM, is structured.
Okay.
You need to know what you're trying to target, within the page's code.
Right. Right.
And finally, familiarity with PHP exception handling is vital for building resilient scrapers that can gracefully manage unexpected situations,
Okay.
like network errors or changes in website layouts.
So it's about having a solid understanding of the underlying, technologies to really leverage these tools effectively.
Yeah, absolutely.
Okay, now, the article even touches on how you might structure, a basic scraping project.
Right.
And it's not just a jumble of scripts.
Oh, no. A well-organized project structure makes your code much easier to manage and maintain.
Right.
The article suggests a SRC directory where you'd house your core scraping logic.
Okay. Within
that, you might have a scraper.php file containing your main scraper class. And potentially a scraper interface.php.
Right.
If you envision, having different types of scrapers that adhere to a common set of methods.
Right.
The composer.json file is really like the nerve center of your project's dependencies.
Okay.
It lists all the external libraries that it relies on.
Right.
And then an examples directory, possibly with a basic scraping.php file, would provide, practical demonstrations of how to use your scraper.
Okay.
This separation of concerns, leads to cleaner and more robust code.
All right, so we're laying, a solid foundation,
Right,
with the right tools and a well-structured project.
Yeah.
Now, the article also gives, a kind of simplified example of a modern scraping setup using a modern scraper class.
Right.
Can you, walk us through the key components of that?
Sure. So the modern scraper class serves as a basic blueprint for a modern scraper.
Okay.
It typically starts by initializing an instance of the Guzzle HTTP client.
Okay.
And you'll often see a constructor method that sets up default configuration options for this client.
Right.
These might include things like a timeout period, to prevent your script from hanging indefinitely on slow connections.
Okay.
Whether to verify SSL certificates, to ensure secure communication with the website.
Right.
And a crucial HTTP header, the user agent. The user agent string, it identifies your scraper to the website server.
Okay.
And providing a polite and informative user agent is a basic aspect of responsible scraping.
So it's like saying, "Hey, I'm a scraper, and here's a little bit about me."
Precisely.
Yeah.
Okay. So the example then outlines a scrape method.
Okay.
This method would take a URL as input, use the configured Guzzle client to send an HTTP request to that URL.
Right.
And upon receiving a successful response, it would create a Symfony crawler object from the HTML content of the response.
Okay.
This crawler object is what allows you to navigate and extract data from the DOM.
Okay.
And finally, the example includes a placeholder for an extract data method.
Okay.
This is where you would implement the specific logic to identify and extract the particular pieces of information that you're interested in from the crawled content.
Right. So the scrape method is, the initial fetch.
Right.
And then the extract data is where we kind of get granular about what what we need.
Exactly. Yeah.
Okay, now, one of the biggest hurdles in scraping modern websites that the article really emphasizes is the prevalence of JavaScript.
Yeah.
It mentions that over 75% of websites now rely on JavaScript frameworks.
That's right.
And that's a huge shift, from the static HTML days.
It is.
So how do these traditional scraping methods, that we've been talking about, how do they handle content that's rendered dynamically by JavaScript?
That's the million-dollar question. Yeah. And oftentimes the answer is not very well.
Okay.
Traditional HTTP clients like Guzzle, they primarily fetch the raw HTML source code,
Right.
as it's initially sent by the web server.
Yeah.
If a website heavily relies on JavaScript to generate or modify significant portions of its content after that initial load,
Right.
that dynamically rendered content simply won't be present in the HTML that Guzzle retrieves.
Okay.
This is where browser automation tools like Puppeteer PHP step in as essential solutions.
Okay. So Puppeteer PHP, that sounds like a game changer for dealing with those dynamic sites.
Right.
And the article introduces it as the go-to solution. So what exactly does it enable you to do?
So you can think of Puppeteer PHP as giving your PHP scraper the power to control a headless Chrome or Chromium browser.
Okay.
Meaning it runs in the background without a visible user interface.
Right.
And this is a fundamental shift because it allows your scraper to actually render the website, execute the JavaScript code, and then interact with the fully rendered document object model. So it's essentially simulating a real user visiting the page with a browser.
So it sees the website not just as code, but as we would visually experience it in our own browser.
Exactly. Yeah.
Okay. And the article gives a simplified example of how you might use Puppeteer.
Yeah.
Can you kind of walk us through that?
Sure. So first, you'd launch an instance of the browser.
Okay.
Then you'd create a new page within that browser and navigate it to the specific URL you want to scrape.
Okay.
And crucially, Puppeteer allows you to tell the browser to wait for certain conditions to be met on the page.
Okay.
In their example, waiting for an element with the CSS selector.dynamic content to appear.
Right.
This ensures that the JavaScript has had sufficient time to execute and render the content you're interested in.
Okay.
Once that dynamic content is loaded, you can then retrieve the complete HTML content of the fully rendered page.
Okay. Yeah.
And from there you can use your familiar parsing tools like Symfony's DOM crawler to extract the specific data points you need.
Right. Right.
And then finally, it's important to close the browser instance to free up resources.
Okay. That sounds incredibly powerful, for accessing content that would otherwise be, invisible to, traditional scrapers.
Yeah, it is.
But it also makes me wonder, does that come with a performance cost?
Ah, that's a very insightful point.
Yeah, because running a full browser in the background, that must be more resource intensive than just a simple HTTP request.
Yeah, browser automation, while incredibly effective for JavaScript heavy sites, it does indeed come with a higher overhead.
Okay.
Compared to making direct HTTP requests with something like Guzzle.
Okay.
It consumes more memory and CPU resources because you're essentially running a full browser engine. So the best practice is often to use browser automation selectively.
Okay.
Only for those parts of a website that absolutely require JavaScript rendering.
Right.
For more static content or for interacting with APIs that provide data directly. Sticking with a lighter weight HTTP client like Guzzle is generally more efficient.
Okay.
It's about choosing the right tool for the specific job at hand.
Okay, that makes perfect sense. Being strategic about when to bring in the big guns of browser automation.
Right.
Now, the article then pivots to a really crucial area, ethical scraping and performance. And it throws out a pretty sobering statistic. 67% of websites actively block, aggressive scrapers.
Yeah.
So that really highlights, the importance of treading carefully.
It does. It absolutely does. Websites are becoming increasingly adept at detecting and blocking automated traffic. Being overly aggressive with your scraping, sending a barrage of requests in rapid succession is a surefire way to get your IP address blacklisted.
Right.
This is why adhering to ethical scraping principles and implementing rate limiting are no longer optional. They're essential for ensuring the longevity of your scraping efforts and respecting the resources of the websites you're accessing.
Yeah.
Rate limiting, at its core, it's about controlling the number of requests your scraper makes to a server within a specific time frame.
Right, and the article gives a basic example of a rate limited scraper class.
Yeah.
How does that mechanism typically work?
So in their example, they illustrate a simple rate limiter that allows, say, 60 requests per minute.
Okay.
The key is that before your scrape method in the rate limited scraper attempts to fetch a page, it first calls a method on the rate limiter.
Okay.
Something like this limit await.
Okay.
And this function, it checks if you've already reached your request limit, within the current time window.
Right.
And if so, it will pause the execution of your script for a short period.
Right.
Until the rate limit resets.
Okay.
Ensuring that you don't overwhelm the target website with too many requests in a short amount of time.
It's like giving the website a chance to catch its breath between your requests.
Exactly. Yeah.
Makes perfect sense, from a responsible scraping perspective.
Yeah, absolutely.
Now, what about when things don't go according to plan?
Right.
The internet, it isn't always reliable.
Right.
The article also discusses the importance of error handling and building resilience into your scrapers.
Yeah, absolutely. Network glitches, temporary server issues, even changes in a website's structure can all lead to failures in your scraping process.
Right.
Building resilience means designing your scraper to gracefully handle these errors and attempt to recover.
Okay.
The article presents a resilient scraper class that includes a scrape with retry method.
Okay.
And this method would try to scrape a given URL. And if it encounters specific types of exceptions, perhaps a request exception from Guzzle, indicating a problem with the HTTP request itself, or an invalid argument exception from Downcrawler, suggesting an issue with the HTML structure it received,
right,
it won't just give up.
Okay.
Instead, it might wait for a short increasing period and then automatically retry the request up to a certain number of attempts.
Okay.
This automatic retry mechanism can significantly improve the reliability of your scraper.
Right.
They even mention using an exponential backup strategy, where the wait time between retries increases with each failed attempt.
Okay.
This is a polite way to give the server more time to recover if it's experiencing temporary issues without bombarding it with repeated immediate requests.
Right. And what happens if it still fails after all those retries?
So in the example, after exhausting the defined number of retry attempts, the scrape with retry method would then throw a custom scraper exception.
Okay.
This is important because it signals to the calling code that the scraping process for that particular URL has ultimately failed.
Right.
This allows you to implement appropriate error handling in your application.
Okay.
Perhaps logging the failure, notifying an administrator, or trying an alternative data source.
So that sounds much more, robust than a script that, just crashes silently.
Exactly, yeah.
Okay, so, performance is, another critical aspect.
Right.
The article touches on several optimization techniques,
Right.
and some of the potential gains are really, impressive,
Yeah.
like to a 300% improvement, with concurrent requests using AMP. I
Right.
mean, that's a huge leap.
It is a significant potential improvement. Traditional PHP, it often operates in a synchronous, single-threaded manner.
Okay.
This means that when your scraper makes a request to a website, it typically waits for that request to complete and the response to be received before it can move on to the next request.
Okay.
For scraping a large number of pages, this sequential approach can be very time consuming.
Right.
Libraries like AMP, they enable asynchronous non-blocking operations in PHP.
Okay.
This allows your scraper to initiate multiple requests concurrently, essentially sending them off at roughly the same time, without having to wait for each one to finish before starting the next.
Right.
When the responses start coming back, your script can process them as they arrive. This concurrency can dramatically reduce the overall time it takes to scrape a large number of pages, leading to those significant performance gains.
Okay, and then there's the idea of selective DOM parsing for memory reduction.
Yeah.
How does that work?
So instead of loading and parsing the entire HTML document into memory all at once, which can be quite resource intensive,
Right.
Especially for very large and complex web pages, selective DOM parsing involves targeting only the specific sections of the DOM that contain the data you're actually interested in extracting.
Okay.
By using precise CSS selectors or XPath queries with DOM crawler, you can isolate those relevant parts of the HTML,
Right.
And avoid processing and storing the rest.
Right.
This focused approach can significantly reduce the memory footprint of your scraper,
Okay.
allowing you to process more pages efficiently, especially when dealing with limited resources or scraping at scale.
Right. Right. And finally, the article mentions efficient caching for better response times.
Right.
That's a classic performance optimization technique.
Exactly. Yeah. If you're scraping data that doesn't change very frequently, perhaps daily or even less often,
Okay.
Implementing caching can provide substantial benefits in terms of both speed and reduced load on the target server.
Right.
By storing previously scraped data locally, you can avoid making redundant requests for the same information.
Right.
When your scraper encounters a URL for which it has cached data, it can simply retrieve the stored version instead of making a new HTTP request. This not only speeds up your scraping operations significantly, but also reduces the number of requests you're sending to the target website,
Right.
Making you a much more considerate scraper.
Right. So we've covered the core tools, handling dynamic content and how to be both performant and ethical.
Right.
The article then transitions into a real-world application with an example of e-commerce product scraping.
Yeah.
Can you give us a sense of how all these pieces might come together in such a scenario?
Sure. So the article presents a product scraper class with a scrape product method.
Okay.
This method would typically take the URL of a specific product page as input.
Right.
It would then use the modern scraping architecture we discussed earlier, likely using Guzzle to fetch the HTML content and Symfony's DOM crawler to parse it. Within the scrape product method, you would use CSS selectors to target the specific HTML elements that contain the desired product information.
Mm-hmm.
For example, you might use a selector like h1.product title to extract the product's name.
Okay.
Another selector like .price to get the price.
Right.
And perhaps other selectors to locate product specifications or image URLs.
Okay.
The article even shows a basic helper method, extract price, which might use a regular expression to clean up the raw price text, removing currency symbols or formatting and convert it into a numerical value that you can work with.
So it's all about identifying the specific HTML structures that hold the information you need on a product page,
Right.
and then using the power of DOM crawler and CSS selectors to precisely extract that data.
Precisely. Yeah. CSS selectors, they provide a very powerful and efficient way to pinpoint those specific elements within the often complex HTML structure of a website.
Right. Now, one section of the article that I always find particularly insightful is developer perspectives.
Yeah.
It's great to kind of get a sense of what what the community is actually doing,
Right.
and what their experiences are.
Yeah.
What were some of the the key takeaways from that part of the article regarding PHP web scraping in practice?
One thing that really stands out is the pragmatic approach, within the PHP development community. While the article acknowledges that Python, with its well-established scrapey framework, often gets a lot of attention in the web scraping world, particularly for very large-scale and intricate projects, it highlights that PHP, especially when leveraging the mature and feature-rich ecosystems of Symfony and Laravel, provides a compelling and powerful alternative
Okay.
for a significant range of scraping tasks, particularly those of moderate